Hello students, welcome to Saras's classes. This video is Inequalities Part 2. In the previous video, we learned some of the properties of inequalities. Now let's continue with some other properties of inequalities. Now in the previous video, we learned property 1 to 7. So we will start this video with property 8. Property 8. Now it states that if A lies between 0 to 1, so if it lies between 0 to 1 and n is any positive rational number, so it is a positive rational number, then we would have a raised to the power n. Now this would be less than 1 and greater than 0. So a raised to the power n would also lie in the interval of 0 to 1. And a raised to the power minus n, a raised to the power minus n, this would be greater than 1. So, when a is between 0 to 1, then a raised to the power n, where n is a positive rational number, then a raised to the power n will also lie in the interval of 0 to 1, and a raised to the power minus n, that is 1 by a raised to the power n, this would be greater than 1. Similarly, suppose if b is greater than 1 and n is any positive rational number, so if it is any positive rational number and our b is greater than 1, in that case b raised to the power n, this would also be greater than 1, and b raised to the power minus n, which is 1 by b raised to the power n, now this would lie in the interval of 0 to 1. So if our b is greater than 1 and n is a positive rational number, then our b raised to the power n, this would also be greater than 1, and our b raised to the power minus n, or 1 by b raised to the power n, this would lie in the interval of 0 to 1. Now suppose we have a which lies in the interval 0 to 1. So if a lies in the interval 0 to 1 and m and n, these are two positive rational numbers, so they are positive rational, numbers. In that case, now suppose m is greater than n, then this would imply that a raised to the power m, this would be less than a raised to the power n. So if a lies in the interval from 0 to 1 and m and n, they are two positive rational numbers such that m is greater than n, then we would have our a raised to the power m, this would be less than a raised to the power n, and if m is less than n, then we would have our a raised to the power m, this would be greater than a raised to the power n. So that is, if a is a number that is between 0 to 1, then the higher power would be actually the smaller number. So as we can see that here m is greater than n, so this would imply that a raised to the power m, this would be smaller than or less than a raised to the power n. Now so it would be our next property, that is property number 11. Now if our a is, now if it is greater than 1 and again n and n, so if m and n, these two are positive rational numbers, so positive rational numbers, then so now if our m would be greater than n, then this would imply that a raised to the power m, this is greater than a raised to the power n. Similarly, if our m is less than n, then we could say that our a raised to the power m, this is less than a raised to the power n. So when a is a number greater than 1, then if m is greater than n, where m and n are positive rational numbers, then this would imply that a raised to the power m, this would be greater than a raised to the power n. Similarly, if m is less than n, then a raised to the power m would be less than a raised to the power n. Now in the next property, that is property number 12, we have if our a is greater than 1 and suppose x is greater than y, which is greater than 0, so x and y both would be greater than 0 and x is greater than y, so then our log base a x, this would be greater than log base a y. So if our a is greater than 1 and we have x greater than y, which is greater than 0, then we would have log base a x, this would be greater than log base a y. And if so, this is 1. Now similarly, if our a, if this lies between the interval 0 to 1, so if a lies in the interval of 0 to 1 and again our x is greater than y, which is greater than 0, then in that situation we will have, so then we would have our log base ax, this would be less than log base a y. So as we can see that if our a is greater than 1, then and if x is greater than y is greater than 0, so now if our a is greater than 1, then log base ax, this would be greater than log base ay, and if our a, this lies between the interval of 0 to 1, then we would have our log base ax, it would be less than log base ay, where our x is greater than y, which is greater than 0. Next property states that for any real number, so for a real number, say a, we would have our a, it would lie in the interval of minus mod of a to mod of a, that is our a would be greater than equals to minus mod of a and it would be less than equals to mod of a. So this is the range for any real number a, that is whatever the value of A is, so it lies between the interval of minus mod of A to plus mod of A. Now, so this is our property number 13. The property number 14 states that it states that if we have r which is greater than equals to 0, so if r is greater than equals to 0 and a is any real number, so if a is any real number and r is greater than equals to 0, then we would have, so suppose x minus a, so mod of x minus a, if this would be less than equals to r, then this would imply that a minus r, this would be less than equals to x, which would be less than equals to a plus r. So the interval of x would be from a minus r to a plus r. Now it is true in the other direction too, that is, if a is any real number and r is greater than equals to 0, such that we would have a minus r is less than equals to x, which is less than equals to a plus r, that is, x lies in the interval of a minus r to a plus r, then this would imply that our x minus a, so mod of x minus a, this would be less than equals to r. Now in the next property, that is our property number 15, it says that if a and b, if these two are positive real numbers, so they are positive real number. So if a and b are positive real numbers such that we have our a is less than b, so our a is less than b, so this would imply that our a plus c divided by b plus c, this would be greater than our a by b. So if we have our a less than b, then this would imply that a plus c divided by b plus c, this would be greater than a by b, where c is greater than 0, that is, for all c greater than 0. Similarly, if our a is greater than b, so if our a is greater than b, so this would imply that a plus c divided by b plus c, this would be smaller than our a divided by b. So when a and b are two positive real numbers such that our a is less than b, then a plus c divided by b plus c, this would be greater than a by b, where c is greater than 0, that is, for all c greater than 0. Similarly, if we have our a greater than b, then this would imply that a plus c divided by b plus c, this would be less than a by b. This would be for all c, again, this would be again for all c greater than 0. Now the next property, that is property number 16, it says that if our a is a positive real number, so if a is a positive real number, so it is a positive real number, then our a plus 1 by a, this would be greater than equals to 2. So when a is a positive real number, then a plus 1 by a would be greater than equals to 2, and when a is negative real number, so it is negative real number, in that case our a plus 1 by a, this would be less than equals to minus 2. So when a is positive real number, then a plus 1 by a would be greater than equals to 2, and when a is negative real number, then a plus 1 by a, this would be less than equals to minus 2. So this is our property number 16. Now next is property number 17. It states that, so next is property number 17. It states that mod of a plus b, this would be less than equals to mod of a plus mod of b. So mod of summation of a plus b, that is mod of a plus b, this would be less than equals to mod of a plus mod of b. Now generally we can write it as, where a mod of a1 plus a2 plus so on till an. Now their mod, this would be less than equals to mod of a1 plus mod of a2 plus so on till mod of an. So the 17th property is that a plus b, the mod of a plus b is less than equals to mod of a plus mod of b. And in generally we can say that mod of a plus a1 plus a2 plus so on till an, this mod would be less than equals to mod of a1 plus mod of a2 so on till plus mod of an. So these are some of the properties, that is elementary properties of inequalities.